Hello programmers, welcome back to this Introduction to Java tutorial series. Today we're going to be talking about some very important concepts in Java, including objects, methods, and constructors. So without further ado, let's get started. As you can see, I've already opened up my IDE, and I've already created two classes for us to take a look at today, these being bank and bank account. One of the crucial things that you need to keep in mind today is that within Java, classes are able to interact with each other, and you're able to use information from different classes and code from different classes in a separate class. This is a very powerful tool that you have available to you, so let's go ahead and learn how to use it. I today am going to be using these two classes to model a real-world bank. So I have one class called bank account and one class called bank. What do you think is the relationship between my bank account class and my bank class? Well, if you guessed that my bank class is going to keep track of a bunch of different bank accounts, then you'd be correct. Let's learn how exactly we do this. So in Java we have something available to us called objects. What is an object? Well, a simple way to think of it is it's just a copy of a class. So over here, we have a bank account class. And the bank account class models a real-life bank account. When we create a bank account object, we create a copy of the bank account class that we can manipulate and do whatever we want to separately without changing bank account. So if I want to make a bunch of different bank accounts and manipulate them individually, I will need to create a bunch of different bank account objects. How do we do this? Well, we are going to need to use the following syntax. So when we are creating an object, these are objects right here, we're going to need to type the title of the class, the name of the class, and then we need to title our object. We need to give our object a name, and then we use equals and new, which triggers the constructor event, something that we'll talk about later. And then once again, type in that class name, and then open parenthesis, close parenthesis if you don't want to put any parameters into your object, and then if you do want to put any parameters or arguments in, what you're going to need to do is type those in, and if there are multiple, separate them by a comma. You might be wondering, how do I know what parameters go into a specific object? We'll talk about that later, and this will make sense once we take a more in-depth look at the bank account class. I'm just showing you how to implement a separate class right now. So, what is this stuff down here? Well, since I have a public static void main, you might have assumed that I want this class to actually do something, and that is correct. I have created two bank accounts, and now I want to manipulate them. So I'm going to use something called a method. A method allows you to follow a sequence of instructions and manipulate data within your objects. So the bank account class has a method called deposit. And if I put a integer value into, a numeric value into deposit, it will deposit that value into my bank account, adding it to my balance, which is right here. It was 60. So now, when I print out my balance, I should see that the balance is equal to 120. Some of you might be wondering, what did I do with this line of code? Well, I printed out a method. I printed out the method. And that might not make sense to you right now, and it will make more sense later once we look at the method itself and how it functions. But for now, what you need to understand is that there is a method within Tim account, so within the bank account class, that retrieves the balance. And so when the computer looks at this line of code, it says, okay, I'm going to go to Tim account, and I'm going to get the balance, and that balance is going to be 120, and it's going to replace this whole line right here with 120, and then it will system.out.print and 120, and it'll print 120 to the console. So when we run this program, as you can see, we have successfully printed 120 to the console. One thing that you'll note is that this method right here, it manipulated the data in Tim's account, and this method right here, it retrieved data from Tim's account. So there are two fundamental types of methods. There are accessor methods and there are mutator methods. As I'm sure you've already guessed, this is an accessor method because it accesses data from Tim's account, and this is a mutator method because it mutates data from Tim's account or changes it. So now that we understand how to use objects, let's go ahead and talk about how we create classes so that they can be implemented as objects. So let's go over to our bank account class. Right now, this probably looks like a bunch of jargon, but hopefully soon this will all make a lot more sense. So this line of code you should already be familiar with. We talked about it in our first tutorial of this series. This is called the class declaration. We declared the class as public. This is the scope. We called it a class and we gave it a name. Let's go ahead and talk about that scope. So within Java, we can have two different scopes. We can have public or private. The reason why we wanted to make this public is because we wanted bank to be able to access bank account in order to make bank account objects. If we had made this private, bank would not have been able to find bank account. Bank account would have been, or bank would have thought that bank account doesn't exist, and we would have gotten problems, which is why we keep this class public. What are these? These are something called instance variables. Instance variables. They are a lot like regular old variables, and in fact, you'll probably recognize this syntax from 2 tutorials ago. Of course, we're declaring the type of the variable, and we're just going ahead and giving it a name, and we are not assigning it a value. So you might be wondering, why are we declaring the scope of the variable? Why are we declaring it as private? And that's because we want these variables to be specific to our bank account class. We don't want other classes to be able to manipulate balance for account holder. Let's say, just for the heck of it, I made these public, and then I created a third class called hacker, and I said in the hacker class, go ahead and go over to bank account and manipulate the balance and make it 0. We wouldn't want that to be able to happen, so we're going to keep these as private. So these are our instance variables. They basically are just variables that represent important data we'll need to keep track of throughout the class. So since we're trying to model a real-life bank account, we need to keep track of balance and, of course, the name of the account holder. So that's why we have these two. Next, let's talk about constructors, which you can see right here. We triggered 2 separate constructor events. We triggered each of these once over here in our bank class. So when we are creating objects, what we're actually doing is we're triggering constructor events, or these segments of code right here. You'll notice that there are multiple, so you might be confused. You might wonder, how does the computer know which constructor event to use when I'm creating an object? Well, it comes down to what parameters are you giving the computer. You see, with this John account, I gave the computer no arguments with my object. So the computer comes over here when it's making this object, and it says, okay, I'm looking for a constructor event with no arguments. This one right here has no arguments. So the computer will follow this code right here when making that object. It'll set the balance to 0 and the account holder name to unknown. However, over here with Tim account, we gave it 2 arguments. We told it 60 and Tim. So it's going to look for something with a numeric input and a string input. And over here with this second constructor, we gave it 2 parameters, give me a balance and give me a name. So it's going to assign the balance of that account to be 60, and it's going to assign the name to be Tim. So now that we understand how exactly constructors work, let's go ahead and talk about methods. We saw our methods earlier. Here's what they look like behind the scenes within the classes. So up here we have our accessor methods. Typically you want to start the name of an accessor method with a word like get, and then typically you're going to want to start the name of a mutator method with a word like set. However, in our case, we're using bank terminology, so So we're going to call our mutator methods withdraw and deposit. Let's go ahead and talk about method syntax real quick. What exactly do you need to do in order to declare a method? Well, it's very simple. Once again, you need to declare the scope. And because we want our methods to be accessible in other classes, like this one, we're going to need to declare the method as public. So declare your method as public. Next, you need to declare the return type of a method. What do I mean by return type? Well, if we go over here and we go down to this line of code right here, we'll notice that when we executed this print statement that had a method inside of it, the method itself was replaced by a number. So the method returned a number. This is what we mean by return type. What is the method returning? Is it returning a string, a double, an integer? In our case, when we want to retrieve the name, the method should return a string to us. Okay, so let's go to the body of the method, which is this bit right here. We see this new keyword, and this is called return. So when this method is executed, once it gets to this line of code right here, line 21, when the computer sees return, it does two key things. Key thing number one, it takes whatever this value is right here, and it sends it back to whatever called the method. So over here, tim.account.getBalance was called. So it went over here, went to getBalance, saw return, and sent balance back to replace timaccount.getBalance. And then the second thing that return does is it terminates the method. So if I had another line of code down here, like balance equals balance plus 2, this would not be executed because the return keyword will terminate the method and just return whatever value it is given. So that is what an accessor method does. Now let's talk about mutator methods, which we have programmed down here. So our first mutator method that we see is withdraw, and we have a new word that I believe we are unfamiliar with called void. So right here we have our scope, and then we go to our return type. What does void mean? Void, you might be actually familiar with it within the English language, but it basically means we're not returning anything. We are returning nothing. And this is because when we are mutating something, we're not retrieving data, we're trying to mess with data and modify it. So we don't need to be returning anything. So this is why we use void. And then once again, we have our method name, and this time we're taking in parameters into our methods. So as with our constructors up here, when we want to take in a parameter, we are going to need to declare the type of parameter, and then we're going to need to give that parameter a name. And so that in the body, if we want to do something with this parameter, for example, since we're messing with withdrawal, we're going to want the parameter of remove a set amount, and then we're going to want to remove that set amount inside the body of the method. So as you can see, we have declared our method header, and then we have a method body which will take the balance and subtract the input that was given here as a parameter. Next, let's talk about the deposit method, which we actually implement over in Bank, and it's pretty much the exact same thing as withdraw, except we add whatever amount we are given instead of subtract it. So now let's go back over to Bank and let's do a quick recap to make sure we understand everything. As you can see, we create two objects. Just one more time to reiterate from earlier, what exactly is an object? It's a copy of a class. So when we created Bank, we created a copy of Bank account, we named it John, and we gave it 0 parameters. So it came over, when it was creating that object, the computer came over here, looked for a constructor event with 0 parameters, saw this one, set the balance to 0, and the account holder name to unknown. So that's our John account. Next, we created an account called Tim account. since we gave the computer two parameters, it came to the bank account class and looked for a constructor event with two parameters. It chose this one because it had first a double parameter and second a string parameter. Perfect match. It set the balance to whatever number was given as the double parameter. So since we gave it 60, it set the balance of Tim account to equal 60, and it set the name of Tim account to equal Tim. So there we go. We have now reiterated what exactly is going on with these objects. And now let's talk about a little bit more about those methods. So when we are creating, or when we're using this method right here, the computer sees, okay, I am manipulating the Tim account object, and I'm going to implement the deposit method, and I have a parameter of 60. So looking back at this method over here, the deposit method, what happens is our parameter is 60, and it takes 60 and it adds it to the balance. And now if I want to see what my new balance of the Tim account is, I'm going to need to use another method, an accessor method called getBalance. And I'm going to take a look at getBalance over here. GetBalance just returns the balance, returns the current value of balance. So this would be replaced with whatever the balance is, and I would print out the balance. That is essentially how these two classes work in tandem to simulate a bank. You can do similar things with any number of real-life objects. You can simulate so many things. This is the power of object-oriented programming. At the very least, I hope you learned something today. These are some very important concepts to master along your path of becoming a Java programmer, and they might seem confusing right now, but I encourage you to keep working with them. Try and program something else that you can simulate from real life. And the more you practice, the more you're going to get out of this. I wish you luck in your programming endeavors, and thank you for watching.